Hi everyone, this is Tom Humphrey from the National Weather Service in Billings, Montana. After the very busy fire weather season of 2012, quite a few areas will be more susceptible to flash flooding over the next couple of years. This presentation will provide an overview of the higher probability of flash floods. Please note that while this presentation highlights some of the bigger burn areas, a similar flash flood threat exists in any burn area, big or small. Before we get into the at-risk locations, allow me to briefly explain why flooding potential increases after a fire. Fire causes a dramatic change to the makeup of the soil composition, not to mention the loss of vegetation which would help absorb precipitation. These two factors cause the soils to be more susceptible to erosion and flash flooding during rain or melting snow events. A post-fire landscape would normally involve an increase in water flow and magnitude in channels and tributaries, and an increase in debris and sediment transport, which in turn increases the probability of debris flows in steep terrain. Debris flow is defined as a moving mass of loose mud, sand, soil, rock, and water that travels downslope under the influence of gravity. The risk of debris flow increases dramatically in the post-fire environment. So what changes after a fire that causes an increased risk of flash flooding? To explain that, we need to first examine the pre-fire environment. In a coniferous forest pre-fire environment, there is a canopy present. There are also two layers above the subsurface soil to help absorb precipitation. One layer is forest litter, which involves anything from shrubbery and grass to deep pine needles. Underneath this layer is a less permeable soil surface which can still absorb precipitation as it falls. In the post-fire environment, both the canopy and forest litter have been burned away. Beneath the burnt surface, the soil becomes hydrophobic or water repellent due to the intense heat of the fire. Above this hydrophobic layer and below the burnt surface is a wettable sand-like layer. This sand-like layer is not very stable and plays a major role in debris flows. In rain events, the top layers absorb all the water since the water can't penetrate the hydrophobic layer. These layers become saturated fairly quickly and will have a tendency to break off and slide downhill in the heavier rain events due to the unstableness of the layers as discussed in the previous slide. This whole process depends on the heaviness of the precipitation, but can happen in as little as 15 to 30 minutes. This breaking away of the soil is what is known as a debris flow. There are several factors that affect the hydrologic response on burn scar areas. The first factor is the steepness of the terrain. The steeper the terrain, the greater the risk for runoff. The second factor is the intensity of the burn. The higher the severity of burn, the more hydrophobic the soil becomes, and thus the greater runoff response. The greatest potential for flash flooding is within the drainage areas that burn the hottest. The third factor is time. The strongest flow response will be in the first year or two after the fire. In the second to third year, the hydrophobic response lessens as growth returns to the area. The fourth factor affecting potential rapid runoff in burn scar areas is rainfall intensity. The harder the rain, the faster the runoff. This is true in normal environments, but even more so in a burned area. Lastly, we need to consider rain falling on melting snow. This process will accelerate the runoff as it acts like an increase in rainfall intensity. All of these factors mentioned play major roles in ultimately determining the rate and magnitude of the hydrologic response in burn-affected terrain. In variable terrain, such as what we have in southern Montana, it typically does not take much more than an inch of rain in an hour's time to produce flash flooding, depending on the steepness of the slopes involved. As you can see by this graphic, it takes even less rain to produce flash flooding, and the response time is shortened dramatically in burn scar areas. Flash flooding and large debris flows will be quite possible with an inch of rain in 2 hours, or as little as a half inch of rain in 1 hour, or even just a third of an inch of rain in about 15 minutes. All of these numbers, of course, will be dependent on rainfall rates and the degree of slope over the terrain, but the message should be clear that flash flood and debris flow potential dramatically rise in burn scar areas and does so in a shorter time span. So what areas are at risk in and near a fire scar? The general answer is all locations downstream and down valley of a burn scar. The most vulnerable locations will be low-lying areas, floodplains, and all existing or historic stream channels where water would want to flow during a rain event. Please note, water and debris can be transported into areas that don't typically see water flow, especially downstream of a burn location. The heavier the rainfall, the more locations downstream of a burn scar are at risk. Therefore, all locations in and downslope of a burn scar should be aware of the increased chance of flash flooding and debris flows. Here's a compilation map showing the largest burn scars from last year's wildfires. Details for these and other fires will be added to our headlines section on our website as the information becomes available. So how can you best prepare if you are in a location that may be impacted by burn scar flooding? First off, have an evacuation route planned out ahead of time. Know the route you will take if flooding or debris flows become a concern. Secondly, build an emergency supply kit for your home and your vehicle. Last and probably most importantly, stay informed of the weather at all times. Stay up to date on the latest forecast from the National Weather Service. Be alert to potential outlooks, watches, and warnings issued for your area. You can track all this information on our website at weather.gov/Billings. Keep your NOAA weather radio handy and activated. You can also track down reports from the National Weather Service on Facebook and Twitter. One thing that needs to be stressed: be proactive. Stay ahead of the event. Do not wait for a warning to be issued to respond. One last thing. If you are not sure if your location is one that could be at risk from burn scar flooding, please contact your local county officials and discuss it with them. They will also be able to help you with potential escape route information if an event were to occur in your vicinity. For those in and near burn scar locations, be alert if any precipitation develops. We have already discussed how quickly water responds in burn scar locations, which makes it that much more difficult to anticipate and forecast. If you experience heavy rain in your vicinity and your area has been identified as one that is at risk, take action quickly. Do not wait for a warning to be issued to evacuate. These situations can and often do develop in a very short period of time. The quicker you respond, the better. Do not drive through moving water, no matter what the perception of depth is. The road may be washed out underneath without your knowledge. Take extra care at night, as it is much more difficult to recognize flooding danger. If you are caught in a flood or debris flow, call 911 immediately. That concludes this video. If you have any questions on the information presented, you can contact the National Weather Service in Billings, Montana. Thank you.